One of the things that students need to know how to do is to locate fractions on a number line. For simple fractions, such as 3/4, we can proceed from the definition. We simply break the unit segment into 4 equal parts. We identify the length of 1/4, and then we move 3 times that length from 0 to the right, and we arrive at the location that represents 3/4. Again, we have the location 3/4 here on the number line, and we also have the length 3/4, which is the length of the segment from 0 to 3/4. In general, for the fraction a over b, we break the unit segment into equally spaced parts, b of them, equal hopefully, and there are b of these parts, and we identify the length 1 over b, which is the distance from 0 to the first segment, and we move a of those segments, 1, 2, 3, a of those segments, whatever that is, and we come to the location a over b. However, there are times when this strategy is not so simple. Take, for example, the fraction 17/36. It would be rather difficult to break the unit segment into 36 segments and count from the left 17 of those. So one strategy is to compare the fraction we're trying to place to what we call benchmark fractions. We look at 17/36 and we recognize that 17 is about half of 36, and therefore the number 17/36 should be somewhere close to the number 1/2. Now we just need to know, is it smaller or larger than 1/2, and by how much? From the definition of fractions, we know that 36 involves breaking the unit segment into 36 equal parts, which is a bunch of them, equal, of course, and that if we move 18 of those 36, we would end up at a half. So 1/2 would be the same as 18/36. Now we can compare our numerator, 17, with 18, and see that 17/36 is really moving only 17/36, a little bit less than 18/36, from 0. And so 17/36 is going to be located slightly to the left of 1/2. Now, slightly in mathematics is not sufficient. We need to be more precise. So exactly how far is that distance right there? Well, we know it's 1/36. This is called locating fractions using a benchmark. 1/2 is the benchmark fraction, a common one that all students should know. Notice that in this case, our benchmark fraction, 18/36, had the same denominator as the fraction that we were trying to locate. It can be a little more complex for a fraction such as 4/15. Again, this is close to a fraction that we might be able to recognize. 15 is close to 16, and 4/16 is 1/4. So we know that our fraction will be pretty close to 1/4, which is equal to 4/16. But now in this case, you'll notice that our benchmark has a different denominator than the number that we're trying to locate, but the numerators are the same. Now the question is, which is larger, 4/15 or 4/16? Well, going back to our definition, we know that if we broke the unit segment into 15 parts, those units would be larger than if we broke the unit segment into 16 parts. Since we have 4 of those parts, 4/15ths, would be larger than 4/16ths. Once again, we need to decide by how much. The answer to that question is going to be pretty difficult to find, maybe not difficult, but tedious at least, using a number line. So we'll save that for another time when we talk more about the abstract and symbolic methods of comparing fractions. Finally, let's talk about placing improper fractions on the number line. We haven't used that word yet. Most of the time when people are talking about fractions, they're talking about numbers that are less than 1. However, as we saw with the definition, we can also represent numbers that are larger than 1 using fractions. 5/4, 6/4, 7/4, 8/4, and so on. Numbers where the numerator is larger than the denominator are called improper fractions. Let's try a simple one first. 13/5, for example. We can use our definition of fractions. Since we're working with fifth, we'll break the unit segment into 5 equally spaced pieces and continue on past 1 and past 2. And then we can simply count 13 of those segments to the right of 0. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and there's our result. 13/5 is right here. But there's a simpler way, of course, and that is to notice that since we're working with fifths, each set of 5/5 represents one whole. So the fraction 13/5 represents 2 sets of 5, 1, 2, plus 3 left over. You may notice that we've essentially determined how many times 5 goes into 13 and kept track of the remainder, 3. The result is often represented as the mixed number 2 and 3/5. So, for the purposes of locating this number, instead of starting at 0 and counting 13, we can start at 2 and simply count the remainder, 3, and we'll get to our number 13/5. We can verify this from our knowledge of fractions by remembering that 2 is equal to 10/5, 2 sets of 5, and if we count 3 more over, we get to our number 13/5. So what about more complicated numbers? Something like 1243 over 165. Well, now clearly a number line is going to be insufficient, and we'll make use of our understanding of the more abstract concepts as we move into these kinds of numbers. First of all, we'll need to find out what whole number is this fraction slightly larger than. So we'll need to know how many times does 165 go into 1243. Well, students are likely to use trial and error here. Let's look, and we can see quickly that it's 165 does not go in 10 times. That would be 1650 is 165 times 10. Let's try maybe 8. 165 times 8, 40, carry a 4, 48, 52, carry a 5. 1 times 8 is 8. That's 13, 20, still a little too big. So we can try 7. 165 times 7, 35, carry 3, 42, 45, carry the 4, 1 times 7, and we get 1155. So we know that we have 7 whole units, and the remainder is 1243 minus 1155, which is, looks like 88. So what we're looking for is 7 and 88 out of 165. So now we can use our benchmark idea. We know that 88 165ths is kind of close to a half. So half of 165 is 82 and a half, 165ths. That's a half, and 88 is going to be greater than that. So if we make our number line from 0 to 7, 0, 1, 2, 3, 4, 5, 6, 7, 0 to 8 actually. Here's 7 and a half. 7. Our fraction is going to be a little bit larger than that, and it's just a little bit larger than 7 and a half, only 5 and a half 165ths. So right about there, hardly bigger at all, is where 1243 165ths will be located on the number line. So you'll notice that working with these numbers and trying to locate them on a number line introduces ideas about mixed numbers, improper fractions, and it's a core idea for students to understand. It's very important that they understand that a fraction is a number, first and foremost. In future sessions, we'll talk about other ideas that fractions can represent, but for now, let's look at some assessment questions that will help you to understand further the ideas that we've introduced in this lesson.